Hello and welcome to Sam-Splaining Science. I'm Sam. I'm your host. I'll be Sam-Splaining the science. And today we're talking about alcohol. I have done an episode in the past on alcohol use disorder, which I believe was episode 29 if you want to scroll all the way back. But today we're talking more about the chemistry of alcohol and going into a little bit more detail about how alcohol is created, brewed, whatever the correct term for that is. So that's what we're doing today. But before I get into that, let's chat. Hello, how are ya? I hope you're doing well. It has been some time, that is for sure. Time moves faster than I think it does. And I don't know why that happens or how that happens, but it does. Because all of a sudden, 3 months have passed-ish since I last made an episode. And it doesn't really feel like 3 months. So I don't really know what that's about. I don't know who I can talk to about that to make time slow down or to just give me more time to make podcast episodes. But it's okay. We're here now. Thank goodness. And I'm getting text messages, and that's fine. And we're just going to silence our phones, as you should do. I mean, not you, me, as I should do. Anyway, how are ya? I hope you're good. I know it's been a while, but things have been busy. I will say this. I did quite a lot of travel in the month of May, and my travel is what inspired this episode. So the first week of May, I was on a work trip, and we had like an international meeting in Portugal. So I was in Lisbon and I was in Porto. Well, Porto was for fun for me. Lisbon was for work. But I went to Portugal and I drank a lot of wine in Portugal, as one does. And it was fantastic. And when I was in Porto, I did a winery tour and walked through some of one of the most famous wineries in Porto, and saw all the big barrels and got to do a wine tasting, which was super fun. And yeah, I did a lot of drinking of wine the first week of May, a lot of alcohol consumption. And then in the last week of May, I went on a trip with my mom and my two sisters back to Europe, to Ireland. And it was amazing. It was honestly my favorite trip ever. Usually when I go away, when I'm done with the trip, like when I come home, I'm like, oh, thank God I'm home. Or like, oh my God, I miss New York. Oh my God, I miss my bed, whatever. This trip, I was genuinely sad to return back to my normal life. Like I really, really did not want to be back. And honestly, some days I think about it and I'm like still sad that I'm back in my real life. And it's been almost 2 months since I got back from Ireland. But it was just awesome. It was so fun and beautiful landscapes. And you guessed it, Guinness. Lots of Guinness. Fun fact about me, I've never had Guinness before. And then the first Guinness that I had was in Dublin. My first day, I landed in Dublin and I got a Guinness, my first ever. And I had at least one Guinness every day that I was in Ireland, which does something to a person. It certainly does. But I actually haven't had Guinness since. So the only time that I've ever consumed Guinness has been in Ireland. And I think that that's just how it's going to stay, frankly. Because everyone tells me, they're like, oh, Ireland has the best Guinness you'll ever have. Like, it's just not the same in the States. So I'm going to believe you. And I'm just going to never drink Guinness unless I go back to Ireland, which I am planning on. I'm planning on actually moving there maybe one day, I hope. Manifesting an Irish citizenship. I know it's not that easy, but I'll try. Screw it. But anyway, the point of this soliloquy about my borderline drinking problem between my trip to Porto, and Ireland was that I drank a lot of alcohol in May. And it got me thinking, one about alcohol use disorder, which I've already done an episode on, so I'm not going to talk about that today. But what it did get me thinking about is alcohol and like winemaking, which I saw in Porto in the winery, in the wine tour, and beer brewing, which I learned a little bit about through the Guinness Storehouse when I was in Dublin, is like, it's literally science. It's science. And like, that's what's so cool and fun about it, is it's like, yeah, maybe I'm doing destructive things to my body, which we'll talk about in a second, but it's like in the name of science, and it's a byproduct of science. So you have to respect it. You don't have to respect it, but I respect it as a scientist and as someone who drinks an occasional wine or beer. So that was the motivation for today's episode, was going to wineries, going to brew the Guinness Storehouse and learning about the brewing process and realizing, oh my God, this is literally science. Let me Sam-splain it to you, because it's science. So without further ado, let's get into the science. Let's talk about today's questions and what we're going to talk about. The first question we have today is, what is alcohol? And this is more just like a general Sam-splaining of alcohol, both in terms of the chemistry of like what makes an alcohol molecule, but then also some of the uses and the side effects of the uses of alcohol, and all my disclaimers about alcohol abuse and that sort of stuff will go into the first question. The second question is, how is alcohol made? And there's kind of three parts to this question that we'll get into. One is just like a general overview of the process that actually creates an alcohol molecule, which is called fermentation. Spoiler alert. We'll get into the specifics of fermentation in this question. But then we'll also break it into two further parts and talk more specifically about how fermentation is used in the beer brewing process and how fermentation is used in the winemaking process. For my friends who drink liquor and prefer maybe a vodka or a whiskey or whatever, I didn't want to read any more articles about alcohol. So I'm only talking about beer and wine. And if you really, really, really are dying to know how whiskey is made, I could do another episode, but I just needed to maximize my time, energy, input to get an episode out before the year of our Lord 2026. So here we are, just talking about beer and wine. But I promise you, it's cool and interesting and nerdy and sciencey, and we love it. So those are the questions that we're going to get into. As always, the sources that I used in learning about these questions are linked in the episode description. So if you want to check them out for yourself, if you want to do some more reading, if you want to fact check me, all those fun things you can do using the links in the episode description. Okay, onwards we go. For question number 1, what is alcohol? So from a chemical standpoint, alcohol is any carbon-containing molecule that has a hydroxyl group attached to it. And a hydroxyl group is essentially an oxygen with a hydrogen tagged onto it. So basically, an alcohol is a chain of carbons with an OH also attached to it. And you can have a number of carbon molecules. It doesn't actually have to be a chain. You can have one carbon with an OH attached to it, and that is methyl alcohol. You can have two carbons next to each other with an OH attached to one of them, and that is ethyl alcohol, also known as ethanol. You can have three carbons in a row, and then an OH is attached to one of them, and that could be something like isopropyl alcohol or rubbing alcohol, as you might know. So there's a bunch of different ways. There's all different types of alcohols, but in terms of alcohol that we can consume, ethanol is the only alcohol that we can consume, with relatively safely. I mean, technically you could drink rubbing alcohol, but you wouldn't really do well. But for ethanol, you can drink a cup not of like pure ethanol, but you can drink something with ethanol in it and you'll be okay, generally speaking. So that is like chemically alcohol. And as we know it, alcohol in terms of beer, wine, liquor, that sort of stuff. These are drinks that have alcohol at a certain percentage, right? So again, it's not going to be pure ethanol. It's going to be maybe 5%. Maybe a good red wine is 14% alcohol. Certain liquors are higher proof. The proof is related to how much alcohol percentage is in the liquor. But essentially, alcohol as we know it is a mixture that includes multiple ethanol molecules. Alcohol is a psychoactive agent. If you've ever consumed alcohol, you may know that it can influence your mental state. It can impact the things that you say, the things that you find funny, the things that you do, the way you perceive things, the way you act, can all be impacted by alcohol consumption. And alcohol is also a depressant, which means that it kind of slows things down or turns things off, which is why too much alcohol can be detrimental to our health, both acutely in like a single day, but also long term. So if you drink too much in a given night, and alcohol is a depressant, it can slow down your respiratory rate. So it'll slow your breathing. And if you don't breathe enough, you die, allegedly. So that's not great, obviously. But alcohol also in the long term can cause significant health risks, including things like liver disease. Alcohol is considered a class 1 carcinogen. So kind of like we think of tobacco or cigarette smoking as like that causes cancer. Alcohol falls in that same class of a carcinogen because regular consumption of alcohol is directly tied to an increased risk of head and neck cancers, of breast cancer, of liver cancer, of colorectal cancers. So it is certainly not great for elevated use long term. The more you drink, the higher your risk is for these health risks and complications. So that's certainly something to keep in mind. And lastly, here, alcohol can be addictive for some people. It can be an addictive substance. We did talk about this a little bit on episode 29, talking about alcohol use disorder. So that's also just something to keep in mind. This slide clearly is not a reigning endorsement for alcohol. So if you don't drink alcohol, good on you. You're certainly protecting your health and preventing addiction. And, maybe you won't experience the psychoactive fun, quote unquote, fun side of it. But I think, it's generally better to not drink alcohol than to drink alcohol. But if you do drink in moderation, that is also cool. I drink in moderation. I feel like it's one of those things where you understand that there's a risk and you do your own risk benefit analysis. And there are certain times when you're in Portugal and you're touring a winery and you sign up for a wine tasting thinking that you're going to get like this much wine in a glass, and they give you full glasses of wine to taste. What am I going to do? I'm going to take a sip and leave it? That's rude. I can't do that. The benefit versus the risk. I don't want to look rude. So I'll drink the wine. And it's fine. And I'm living to tell the tale. Knock wood. Anyway, when you're drinking in moderation, if you do drink in moderation, you're thinking, how the hell did this beer come to exist? How did this beer get to me in my hands? I'll tell you in question number 2, which we're getting to right now. So the second question, and technically the last question for this episode, although we still have quite a bit to go, is, how is alcohol made? So this section of the episode, I learned a lot about alcohol creation through alcohol fermentation from the article by Alba Lois and Sigal Kajewski, which is linked below if you want to check it out. But the long answer short for this question is that alcohol is made during a process called alcohol fermentation. And fermentation, you might have heard of it. You might have heard of like fermented this, right? Like maybe you've even heard of wine called like fermented grapes or, you know, fermented whatever. I don't know. I'm thinking of like a fermented cabbage. Isn't that like sauerkraut? Probably, maybe. I made it up. Maybe not. I don't know. Fermentation is a thing, is what I'm trying to say. Maybe you've heard of it. It's a process, a step that happens during cellular respiration. Cellular respiration being the process of converting sugar or sugar-containing molecules down into usable energy for our cells, which typically we as humans and a lot of other eukaryotic cells use a molecule called ATP or adenosine triphosphate as like energy, essentially. So these are like energy molecules that our cells can use to do things. What things? I don't know. You'll have to ask the cells. I can't really speak to that. But the process of cellular respiration essentially takes the sugar or sugar-containing molecules and breaks it down into usable energy by using oxygen and creating energy, carbon dioxide, and water. That's sort of like as a whole, the cellular respiration pathway. Fermentation can occur as a step in that pathway. And we'll kind of get into what that looks like. So the first step of cellular respiration, you have a glucose molecule, let's say. Glucose is a sugar, as you may have heard. Chemically, glucose is a molecule that has 6 carbons, and it's kind of shaped in a ring. And the very first step of respiration, cellular respiration, is the breakdown of glucose, a 6-carbon molecule, into 2-pyruvate, where pyruvate is basically just like a smaller molecule that has 3 carbons each. So essentially, you're cutting that glucose in half. You can think of it like that, where it used to have 6 carbons. Now there's 2 molecules with 3 carbons each. In the presence of oxygen, those 2 pyruvate molecules, those 2 3-carbon molecules, will go through a process that will eventually give lots and lots and lots of ATP, or lots and lots and lots of energy. So that is like the favorable pipeline for a cell, is to take those 2 pyruvate and put them through an oxygen dependent cycle that we're not going to get into today, but that's all you need to know about that. And again, that is something that our cells normally do. That's like the preferred way to go about it, because you make a lot of energy from it, and it's what our cells do most of the time. But when oxygen is not present, those pyruvate 2 3-carbon molecules can do one of 2 things. It can be converted into alcohol and carbon dioxide through a process called alcoholic fermentation, or it can be converted into lactic acid through the lactic acid fermentation pathway. So humans, we do lactic acid fermentation. In the case that we don't have sufficient oxygen, our cells will continue through the cellular respiration pathway using lactic acid fermentation. And you might be familiar with this. Like, have you ever exercised really hard or like ran really far, and then the next day you're sore, and maybe someone's told you, oh, that's like the lactic acid building up in your muscles? So when you have lactic acid buildup in your muscles, it's essentially your muscle cells during your workout, during your run, during your weightlifting or whatever, maybe didn't have sufficient oxygen. So instead of going through the energetically favorable pathway to get lots and lots of ATP, the pyruvate in your muscle cells underwent lactic acid fermentation to create some more ATP, but not as much energy. And that is kind of what our cells as humans can do. Unfortunately, our cells are not able to undergo alcohol fermentation. I'm devastated to report that when our cells don't get enough oxygen during a workout, we can't make ethanol, tragically. But yeast can. So yeast, which I'm sure we've all interacted with yeast at some point in our lives. Yeast are a single-celled microorganism. They're eukaryotic cells that can undergo alcohol fermentation in an environment that does not have sufficient oxygen to undergo the typical cellular respiration pathway. So yeast can typically undergo alcohol fermentation to make ethanol that is used for brewing beer and making wine. And another part of this alcohol fermentation, in addition to creating ethanol, it also creates carbon dioxide as a byproduct. So for example, in beer, there's bubbles in the foam or bubbles in the beer itself, like the carbonation. Those bubbles, those air bubbles, are essentially the result of the carbon dioxide formed during the fermentation process from the yeast. In the alcohol fermentation process, there are a couple of steps that can influence the efficiency of the ethanol creation. Things like temperature and air exposure are key in this process. Again, the fermentation pathway only really happens in the absence of oxygen. So this is a process that you have to really have controlled air exposure. So we'll get into this in a little bit, like when we talk about the beer making, or the beer brewing, but like the what's the word I'm thinking of? The containers, you know what I'm talking about, the barrels, whatever. Those typically are they're airtight sealed, because during the fermentation process, if yeast have access to oxygen, they're not going to do the fermentation because it's not energetically favorable to them. So things like that. Also, the temperature can influence the activity of the yeast, which can influence the speed of the fermentation process. So things like temperature and air exposure are things that kind of fluctuate through the brewing and winemaking process to impact the outcome, which is, again, the wine or the beer. So essentially, long story long, the process of making alcohol includes a sugar supply, like glucose, but oftentimes in brewing or in winemaking, you'll have something like fruit, or for winemaking, it's fruit. For beer, it's like wheat, like barley or something that you can use to make a sugar supply. You add yeast to that sugar supply. You control the temperature, you control the oxygen exposure, and that allows fermentation to happen, the alcohol fermentation to happen. And then once the alcohol fermentation happens, the end result is ethanol, which is the alcohol that we drink. So that's how alcohol is made. Now, if that's all you really wanted to know, you could really end the episode here. And I wouldn't blame you, to be honest, because this is really like the TLDR. But if you're really curious about beer specifically or wine specifically, we're going to get into that right now. So our next question is, how is beer made? The stuff that we actually drink. How is it made? I learned a lot about the brewing process and like the microbiology behind the brewing process from the Bakulich papers that are listed here and listed in the episode description. So feel free to check those out if you want to learn more. But as we know, as we just talked about, making alcohol requires yeast to do the fermentation process, the alcohol fermentation process. And when it comes to brewing beer, different yeasts make different types of beer. So if you're a beer drinker, you're aware that there's ales, there's lagers, there's different types of beer. And the way that the beer is made, or I guess the resulting beer, can be influenced by the different strains or species of yeast that are used in the fermentation process. So for example, if you're drinking an ale, there likely was an ale yeast that was used in that brewing process. Ale yeast tend to be top fermenting. And what that means is basically in the mixture of the sugar and the yeast tend to float on top of that mixture. They kind of like rise to the top of the vessel. And then there's also lager yeasts, which are bottom fermenting. And that is, as you can imagine, the opposite. Instead of floating to the top, they sink to the bottom. So there's like slight differences there, and that can impact things like the beer flavor, beer color, things of that nature. So the little microorganisms of the yeast can really have an impact on the final product of the beer. When making beer, there's a couple of key steps that have to happen. So again, we know that the fermentation process relies on a sugar source and the yeast. So when we're making beer, who's we? Not me. I've never made beer a day in my life. But when the brewing experts are making beer, there's a process called malting. And the malting process essentially converts grains like barley, for example, or other starches down into sugars. So these starches, these wheats, grains, whatever you want to call them, are really like, they're complex carbohydrates, which means that they basically are like a lot of sugar molecules all connected to one another. And this malting process can help to kind of break them down into smaller, more simple sugars that then the yeast can break down. So the malting process includes 3 steps. There's steeping, germination, and kilning. So the steeping is kind of just like it sounds, like if you're steeping tea. The steeping process, or the steeping step of the malting process, is when you take the grain, the barley, the wheat, and you just kind of like soak it in liquid. And then the germination step breaks down the wheat when you add malt enzymes to that liquid mixture from the steeping. And then those enzymes, those malting enzymes, break down the wheat into smaller sugars that the yeast can then ferment. And then the final step of the malting process is called kilning. And this is basically when that big mixture of liquid and wheat is reduced down. So it removes a lot of the moisture from that malt, as it's called, to a kind of more concentrated liquid. Yum. But the kilning process can reduce the malt from 45% to 5% moisture content. So it really is just like making a super concentrated liquid. I have never seen it. I imagine it's like a syrup or something. That's like what I'm picturing in my mind. I don't know if that's true or not. But that's what it sounds like, because it doesn't sound very, I don't know, whatever. Anyway, so that's the malting process. So after those steps, you have the malt. The next step is called, actually, I don't know what the next step is called. But basically, once you have the malt, you can kind of mash it, is how it's described. mash the malt to make the wort. That's wort. I don't know how to pronounce that. Wort. I guess wort. No. It doesn't even sound like a word. Like, am I crazy? I am a little crazy, but like wort. English is my first and my only language. And it's a 4-letter word that I'm like, I can't. Wort. It literally doesn't sound weird. It doesn't. Now I can't even speak. This is a problem. Okay. Anyway, the malt, which is like the syrupy stuff, gets mashed to make wort. I don't know why I did this to myself. I could have just skipped this whole question. But here I am. Anyway, so basically you have this like mush of sugary paste that was once barley. It was once a grain. It was once a wheat, right? But now it's like this like mush that you can then first acidify. So you kind of have to add some acid to it, but you don't add acid directly. What some brewers do is they add lactic acid bacteria, or lab, to the mash, to the wort, whatever you want to call it. And that can impact the foam stability of the beer. It can impact the flavor of the beer, the color of the beer, that sort of stuff. So based on the acidity, you can add acid or add the lactic acid bacteria to the wort to impact the flavor. And then after you kind of mash that all together and acidify it, you can boil the wort. And that boiling of the wort is really just to sterilize it, to make sure that there's no like weird bacteria or microorganisms or anything. Because at this point, any microorganisms, yeast or otherwise, in the mixture is going to mess with the flavor or the color or the outcome essentially of the beer. So you want to sterilize it by boiling it to kill everything in it. And then after it's sterilized, you chill the wort. And again, now this is just like sugar paste with a little bit of acid in it and no microorganisms because you boiled it. And then once that's created, you can then finally mix with the yeast. And then the yeast are all over that. And they're like, this is delicious. Yeast, one thing about yeast, they love the wort. I have no idea. I don't know. But basically, the yeast then can take the wort as like a digestible, fermentable sugar. And once the wort and the yeast I literally can't talk anymore. I hate this. Why did I do this to myself? Once the yeast and the wort are mixed, you can put them in a temperature and oxygen controlled tub. Why is that word so hard for me to remember? What is it called? A vessel. We'll call it a vessel. Anyway, that can, and then that in and of itself makes the beer. In addition, before that is like completely finished, right? Like once the yeast is fermenting and creating the ethanol by breaking down the wort, you can also add hops into a beer. So hops can impact the flavor of beer. I don't know. I'm not really a big beer drinker. Like I'll drink beer if I have to, but it's not my favorite. I don't know if you drink beer, if you're familiar with like, oh, this beer tastes hoppy. It tastes like armpits, honestly. I don't like a hoppy beer. I mean, I don't like beer in general, but like hoppy beers literally taste like a sweaty armpit. Not that I've ever tasted a sweaty armpit, but it's kind of like a hoppy beer. Like when you drink it, you're just like, if I had to have tasted a sweaty armpit, I feel like it would be the same thing. It's just, I was going to say it's spicy. That's so white girl of me. Hoppy beers are spicy. No, there's just like a weird. It's not great unless you like it. In which case, you can have mine. More for you. But in addition to impacting the flavor of beer, hops also serve a functional purpose in beer. Hops have antibacterial properties. So they kind of like act as a preservative and make sure that the flavor of the beer can like stay awful. Who said that? Not me. That the flavor of the beer can stay constant and like not really fluctuate with time or with, exposure to oxygen or whatever. Hops can also prevent the growth of acetic acid bacteria. So there could be some bacteria. Well, there shouldn't be bacteria in your beer, but if it can be, what's it called? Why am I so bad at recalling words today? Probably because I'm sleepy. That's probably why. I did not sleep well. I think the word that I'm looking for is, it's not infected. It's not infiltrated. It's like, what is it called? This is going to kill me. This is scary. Anyway, we'll say infiltrated, but that's not the right word either. Sometimes acetic acid bacteria can get into beer when it's not supposed to be there. And there's a better word for what I'm trying to say, but I can't think of the goddamn word. And I guarantee you, like, I'll be going to bed tonight and I'll be like, oh my God, that's the word. But I can't think of it right now. And that's so sad, but I have to move on. Otherwise, I'll be here until tomorrow thinking of this stupid word. Okay. But anyway, acetic acid bacteria can grow in beer when it's not supposed to, but because hops have antibacterial skills, or properties, I guess, not skills. Again, words are really hard for me right now. I don't know what's happening. The hops can prevent the growth of acetic acid bacteria. So acetic acid bacteria can create, we're in the presence of oxygen. Acetic acid bacteria can oxidize the ethanol, the alcohol in beer. And then the oxidation of the ethanol creates acetate, which is also known as vinegar. So the presence of this acetic acid bacteria in your beer will essentially turn your beer into vinegar. So the hops having their antibacterial properties can prevent that from happening. So that's an example of how hops are, I guess, needed in beer or favorable for beer. But I'm trying to think. I think I consume more vinegar than I do beer. So maybe that's not such a bad thing. Just kidding. That would be really gross, actually. Just drinking a bottle of vinegar. Pass. Okay. We're almost through this, I promise. So you can add in the hops, and then that's essentially beer. Once that fermentation happens, once the hops are added, you've got your beer, and then you're ready to pack it and distribute it. So during the brewing process, again, because who's we? Because the brewers need to kind of control the amount of oxygen in the environment so that the yeast undergo fermentation. A lot of the vessels that are used for brewing are like steel containers that are airtight to prevent any oxygen from getting in. And then for like packing and distributing, as you're aware, typically beer is distributed in like glass or aluminum sealed containers, again, to prevent oxygen from getting in. So that is typically how beer is packed and distributed, to prevent oxygen from getting in and spoiling potentially the beer. One last thing I wanted to talk about here is fermentation control. So again, we kind of talked about how like temperature and oxygen can impact the fermentation process. There are other factors that can contribute to the differential output or outcome of a fermentation process. And that includes things like yeast quantity and yeast health, right? Like, are the yeast healthy? Are they active? Are they going through the fermentation process as they should? Because if not, then the beer is not going to come out correctly. Oxygen input, which again, we talked about, like the steel containers that are used during the brewing process to prevent oxygen from leaking in. Things like the wort. I thought I was done with that word, but here it comes again in my notes. The composition of the wort can also impact the fermentation. So essentially like the nutritional composition of the wort can also determine how well or how efficiently the yeast are undergoing fermentation. And temperature, because the rate of fermentation can be sensitive to extreme temperatures. So it's important to control the temperature and the exposure of the fermentation at different times, right? And there are points in the brewing process where you do have to like boil the wort to make sure that it's sterilized, but then it gets to a certain point where you need to reduce the temperature in order to, from boiling in order to have the yeast ferment properly. So those are all things that can impact the fermentation process. And just in case I lost you with the science here, I did want to add an extra picture on the slide of me at the Guinness storehouse with a split G in my Guinness. It did take me 2 tries. I did take one large sip, but it was not quite split G. So I did have to take another sip. So I did cheat here. But then there was another time at a dinner, I think it was the next day, where I did split the G on my first try. So I'm just putting that out there. I do have photo evidence of that somewhere. I think my sister has it. This was the only picture that I had from the Guinness storehouse, where I was the only one in my party to drink Guinness. My mom and my 2 sisters do not drink. You think I don't drink beer? They really don't drink beer. I'll drink a Guinness in Ireland. Twist my arm. They won't. So this is photographic evidence of me at the Guinness storehouse with a split G. And this is a picture that I show to people who say, "You don't look Irish." Tell that to her. Look at her. That's an Irish gal if I've ever seen one. You're damn right. Okay. That's how beer is made. Let's move on to wine. Wine. Okay. For wine, again, the fermentation process is it is the same, right? The alcohol fermentation, taking the yeast, take a sugar, they break it down, they make ethanol. But for wine, the fermentation uses sugars from fruit instead of sugars from barley or wheat or whatever. In the wort. Trigger warning, wort. Anyway, so for winemaking, there isn't a malting process or anything like that. It really is just the sugar coming from usually grapes, but sometimes there's a peach wine. Sometimes there's a wine that has like blueberries in it or whatever the hell, right? Fruit essentially will supply the sugar source for the yeast to undergo fermentation. And again, there are a lot of things to control when it comes to fermenting and making wine, including things like oxygen and making sure that there's no oxygen or very little oxygen so that the yeast choose to undergo fermentation. But another thing that's important when it comes to wine is the timing of the fermentation. So if the fermentation goes too quickly, if it goes too fast, that can lead to a reduction in wine quality. But if the fermentation takes too long, that can also lead to damage of the wine. So essentially, what I got from this paper that's linked below, the sablarolis paper. That's not at all how you pronounce that. I apologize for butchering the last name. But essentially, what I got is that you need sort of like this happy medium of timing for the fermentation process to make sure that it's not so fast that the wine quality is trash, but also not so slow that the wine comes out also trash. Is that informative at all? Probably not, but that's what I took away from this paper. There are also things that can impact fermentation during the winemaking process. So that includes the yeast strain. I actually didn't say the yeast strain for the beer. The strains of yeast are, if you think I'm butchering last names today, if you had me pronounce the strains of yeast, we'd have a big old problem. But for wine, the most common yeast strain, which actually is a common yeast strain for ales as well, is Saccharomyces cerevisiae, which I think I use as a face wash. Just kidding. That's CeraVe. That was a joke. Anyway, that's the most common yeast strain that's used in winemaking because it has a very high fermentation capacity. So the impact of like different strains of yeast can have like differential impacts on fermentation. So for example, there's different strains of yeast have different demands for oxygen and nitrogen and other nutrients. So the smaller the yeast cell population and the lower the rate of carbon dioxide production through the fermentation process means that the fermentation process is more viable or more productive, I guess, or more possible. And what impact that has on wine is that the different strains that have different fermentation viability can lead to changes in like the fruity character of the wine, and can also improve some specific characteristics in different types of wine, like a Chardonnay versus a Sauvignon. And then it can also limit the production of organic acids. So it can kind of keep wine on the sweeter side or keep it a little more dry, a little more acidic. And it can also increase the production of glycerol to help, again, contribute to the sweetness of the wine. Another thing that can impact fermentation is the temperature of wine making. So white wines, I didn't know this, but white and red wines tend to ferment at different temperatures. So white wines tend to ferment at about 15 degrees Celsius, reds at about 30 degrees Celsius. And the final temperature of the fermentation is kind of like controlled at that level depending on what type of wine. But there's not really like a cooling process. Like, you know how for the beer we had like the boiling of the wort and then we cool it to get to the fermentation. And it's like a very controlled process. For wine, from my understanding of this paper, it doesn't seem to be as controlled or as important. But I think where it becomes important is the types of wines and like where the temperature should be during the fermentation of different types of wines. But like once you're fermenting, the changes are not extreme. One last thing I'll say about temperature and the impact on the wine is that lower temperatures can increase the production of things called esters and acetates, which are basically like different chemicals, but these can have impacts on the aroma, like the aromatics of the wine, which can impact the smell and the taste of the wine. But low temperatures can also result in what's called sluggish fermentation, which basically just means that the fermentation is going very slowly. And getting back to an earlier point that we made, there's sort of like a happy medium when it comes to fermentation speed. So slowing the fermentation down is not always great. So when the fermentation is slow, and there's like different indicators that I'm not going to get into, but there's different indicators to see if the fermentation is going slowly. You can increase the temperature at the end of the fermentation to increase the speed of the fermentation to kind of get to that happy medium. So that's all I'll say about temperature. And then the last point here is nutrient addition. This is another thing that can impact the fermentation process. They listed here ammonia, nitrogen, and oxygen. So in order to increase the fermentation rate or lower the fermentation duration or how long it takes to ferment, you can add in ammonia or nitrogen or oxygen to impact that speed, to increase the rate, to speed up the process. I also mentioned oxygen addition as a nutrient addition, and that sounds like kind of counterintuitive from what we've already covered in talking about how fermentation is a process that should happen in the absence of oxygen. So adding oxygen might be a little like, why would you do that? But from what I understood from this paper, sometimes oxygen can be added to the end of the fermentation process. So once it's kind of coming to a close, and adding that oxygen can help to maintain the cell viability of the yeast. One important thing to note, though, is that yeast typically can't live or survive in like high alcohol concentration environment. So usually around like 10 to 15% alcohol, which is the alcohol percentage in most red wines, I think, yeast tend to die off. But the point here is adding alcohol can help to maintain the cell viability towards the end of the fermentation. So as fermentation is happening and alcohol is being made and the percentage of alcohol in that wine is increasing, the yeast are dying because they don't like alcohol in their environment. So they'll die off. I think, from my understanding, the point of adding the oxygen in at the end of fermentation is to try to get the yeast to continue to survive, to live, to undergo fermentation as much as they can until they all die off, until you get to like 14, 15% alcohol or whatever it is. That kind of kills them. That's my understanding. I hope that's correct. If it's not, and you're a professional winemaker, please let me know. But that's what I took away from it. And then another nutrient that can be added during the winemaking process is magnesium. Magnesium can contribute to the growth rate of the yeast, again, which means better fermentation. It can also help with sugar degradation, which makes it easier for the yeast to ferment the sugar. And it can also protect yeast from stress factors. I almost said stress fractures, like yeast can break a toe or something. No, they don't have toes. They're one cell only. So magnesium can help the yeast from stress. The more you know. This paper had figures that honestly were kind of boring and kind of confusing, and I didn't really want to add any. So I wanted to fill up the space on this slide with pictures from my camera roll that has not backed up to iCloud in over 2 years because I refuse to buy more storage from Apple. So I figured here's some wines. Ironically, these are all white wines, I'm just realizing, and I'm more of a red wine girl. But for some reason, I'm here. I'll say this top photo was me during, I want to say it was 2017 during the Yankees postseason. If you know, you know. 2017 was a tough one for us. Only because the Astros cheated. Never forget and never forgive either. The bottom one on the left-hand side is white wine in a beaker. And I think this was at a research conference that I was at. I want to say in like Atlanta. At like some bar we went to, and we got wine in a beaker. And science, again, wine is science, guys. Proof right here. And then this picture on the bottom right is actually when I was in Porto. I don't know if you can tell the architecture in the background and the tiles on the building. That's Portugal, baby. One thing about Portugal, they love tiles. And I got to tell you, they're beautiful, as they should love their tiles because they're stunning. But yeah, this is some of my pictures because the figures from the paper were boring and I didn't want to walk through them. Shout out to laziness. Shout out to willingly being ignorant and lazy. Love that for me. Okay, let's get into our final takeaways from this episode. So hopefully you've learned a little bit about alcohol and how alcohol is made through alcohol fermentation, which is a process that naturally occurs in many strains of yeast. And alcohol fermentation basically takes a sugar source, gives it to yeast in a controlled environment, so temperature controlled and oxygen controlled environment, so that those yeast can create alcohol along with other byproducts like carbon dioxide. And then my last note here is not a high note. Excuse me. It's not a high note or a fun note, but it is just a disclaimer that we talked about at the beginning that alcohol can be addictive and it can elevate your risk for health problems, including liver disease and certain types of cancer. So it should be consumed in moderation. And if you or a loved one are using alcohol or other substances more than moderately in a way that is abusive or addictive, I encourage you to reach out to SAMHSA, that's a Substance Abuse and Mental Health Services Administration. You can call them at 1-800-662-4357, or you can go to samhsa.gov for more information. Because as fun as alcohol can be, it can be 1,000 times more detrimental to our health if we're not careful with the way that we consume it. So care for yourself, take care of yourselves, take care of the people that you love. And yeah, that's the worst way to end a sentence. Yeah. But I highly encourage you, if you're somebody who is struggling or you know somebody is struggling, there's a lot of resources out there. So please do reach out. All right. That is all for this week's episode. Please don't forget to follow, rate, and review the podcast wherever you're listening, and also subscribe on YouTube, please. You can also follow the show on Instagram and Blue Sky and TikTok at samsplainingsci. So you can connect with me there and you can ask questions if you'd like. Ask questions through the DMs, or you can submit your questions at samsplainingscience.com/ask. So if you have anything that you want samsplained to you, ask away. Thank you so much for listening to this week's episode. I hope you learned a little bit and laughed a little bit, and I will talk to you next time. Bye.